Aloha, Richard Halverson here. This is ITS148, and today is March 10th. And let me share my screen, show you where we are. Okay, so yesterday we finished up, today is March 10th. So yesterday we finished this chapter, and we need to do 411 and 412. And I was going to have the programming assignment for you today, but it's very similar to 411. It's just I'm going to just change the context of it, but the same kind of a program. So I think today I'm just going to try to get through these two labs because you got to do them anyway. So let's go here. Let's say 14, 11, and 12 or something. Okay, let's go here. Recursion. We just finished that chapter. Interesting chapter. You know, it's not until we get into trees and balanced trees where recursive algorithms really come in handy. Until then, it's kind of like it's like why do we do it the recursive way? It's too hard to understand what's going on in your head. But when we get down to trees and balanced trees, you'll see it's really convenient to think of things recursively. So, but we're learning it now. So let's try this lab here, all permutations of names. Okay, so with this lab, we're supposed to generate all the permutations of names that you can come up with using however many names are input. In this case, in this example here, we have input 3 names. Okay, and these can be names, they can be they can be cities, you know, a sequence of cities to travel, they can be just all kinds of things. And basically we're generating all the possible combinations that you can have of these 3. This is generate the number of combinations without replacement. So it's easy to count up how many possibilities there are. It's 3 times 2 times 1. There's 3 possibilities for the first name, and then after that there's 2 possibilities for the 2 additional possibilities for the second name, and for the second name, and the last name is just 1. So here we see for Julia, we started with Julia, and so we're going to do Julia, then we're going to do Lucas, then we're going to do Mia. And when we're on Julia, we're going to take the remaining 2, which is Lucas and Mia, and we're going to do Lucas, and then we're going to do Julia with Mia. But once we have Julia and Lucas, there's only 1 left, and so that's Mia. And once we have Julia and Mia, there's only 1 left, and that's Lucas. So this is going to be handled with some for loops. We're going to copy over. We're going to want to we're going to read in the list of names. We're going to create a list of permutations, and there's going to be 6 for this particular case here. There's going to be 6 permutations, and this is going to generate all the permutations. So this is going to be this goes in empty, comes back, it comes back full, and this is the list that it was sent. Okay, or the list that you typed in, the list of names split already. So we have to type in this, we have to do this thing here which generates all the permutations. So let's I'm gonna create a new, that wasn't this one, was it? So let me just get rid of all this. And this is test.py, and we have our CMD. By the way, got a new my window Windows 11 updated, and now I've got the date and the time on every screen. That's great. It didn't have it for a while, and I was freaking out. I started posting this thing up in the upper right-hand corner of one of my screens. These are all the time zones I care about right now. But anyway, it's pretty cool. All right, so I'm going to copy this. I'm going to copy it over here. Start with this, and I'm going to put in some code here to take the permutations that were read in and generate all the possible combinations. So, and this is going to be a recursive function, obviously. It's going to be a recursive function. That's what we're doing here. So, all right. So the the way this is going to work is I'm going to first of all, okay, this is going to start out by passing whatever this is plus the name list, and this comes in and it's going to generate all the possible permutations for this name list. Okay, and this name list is, when it starts out, it's going to have 3. Okay, but then what I'm going to do is somewhere along the line, I'm going to call all permutations again, all permutations. I'm going to call it again, and I'm going to be sending it a new list, a new perm list, and that's going to be a copy of the old perm list. So let's make this copy now. I'm going to take the it's going to be the I'm going to say new perm list, because I'm going to pass it down because I have to retain the old one because I have to. New perm list equals the current perm list. It just came in, and it's a copy of it. This is how you do a copy of it. So we've copied the list over into something called new perm list, and then I'm going to let's see. I should take a different approach to this. This is I have the solution here, and I want to explain it in a way that's easy for you guys to understand, because you're going to have to do something like this for the assignment. Okay, so if we have a when this thing is called, the first time it's going to be called, this thing doesn't this thing doesn't have anything in it, and this has the list of names that it's going to create permutations of. And each time we call it again, we're going to be calling it with a new list of names. And that new list of names is going to be one name less. Okay, so the way it's going to work is, the first time it's called, it's going to be called with the full list, and then we're going to use recursion to call this method again to generate the permutations for okay, so the first time it's called, it's going to generate it's going to go through all 3 of these, and the next time it's called, it's going to just ask for the permutation of these 2, and the third time it's called, these are nested recursive calls. The third time it's called, it's just going to have a 1 when it's produced this and this, and it gets called again. There's only one name left in the list to permutate or to permute, and that would be Mia in this case. So the termination condition, we're going to have to look at the size. Let's figure out the size of name list, because each time we call it, name list is going to get smaller, and it's going to be when name list gets down to to an empty list where we terminate it and we start return. So this is the length of name list that's coming in. And then if the size is 0, then if the size is 0, then we've generated all the possibilities. So we want to print this out. So I'm going to do for I in range of the length of the perm list that's just came in, the length of that, print the permutation, and each element is a permutation. It's this is 1, this is 2, this is 3. It's going to be 6 in here. So we're going to print this is print the perm list for how many of them there are in there, and then don't make a and then at the end we're going to print. This should be indented. Print. Now, if the size is not 0, then we want to generate the permutation for the. Here, let's see how this works now. Else, we want to. This is going to be indented because it's part of the else. Else, we want to do for I in the range. Of the length of name list for all of these, for all of the and I could have just put size here, for I in the range of size, for each name that's remaining in the name list. We want to create a new list, which is a copy of the current list. We want to attach to the new list the first name, and we're gonna loop through all the names. So the first time we come in, we're gonna loop through, Julia, Lucas, and Mia, and then the next time we come in here, it's gonna be because we have Julia already appended, and we're gonna loop through Lucas, and Mia, and so on. So this is going to be name list of I. So we're going to append onto the name list, and we're going to remove. We're going to create a new, because these things lists are mutable. So we always want to pass copies. We don't want to pass the list itself. If we don't want it to be manipulated. Okay. So here we're making another copy, new name list is equal to name list copy, and then we're going to pop off the last one because we attached it to this. Since we attached it to this, we want to pop off what we attached, and then we want to go ahead and call all permutations again. And this time we're going to call it with a new perm list and with a new name list. Okay. Now I'm going to run this. Okay, I don't need this anymore. So I'm going to run this, but I want to print out I think I want to print out these as we go. So when we loop through this, I want to right here, I'm going to print I know what I'm going to do. I'm going to do this technique that we talked about earlier. And this is going to be indent. And then this is going to be indent concatenated with 3 more spaces. And so now every time we print inside here, it's going to be indented because this is going to be calling itself, and each time we nest further in, it'll be indented more. And right here, I want to print the first. I got to print indent, and then I want to print what perm list is. So let me do that. With the perm list that came in equals perm list. It's just going to do. Well, I'm just going to see what this is. I don't know what I'm doing here. I'll tell you what, I'm just going to run this. I'm going to see if this works. It won't do me any good if it doesn't work. CD desktop ITS148 CD OneDrive CD desktop CD ITS148 and so I do Python test.py, and it says invalid syntax. I need a colon, missing colon. Something's wrong right there. It's this one here. I need a colon. So let's run it again. And I'm going to write here, I'm going to say enter names. Just so I know what's going on. Save this, run it. And names, Julia, Lucas, Mia. Line 15, inside all permutations. It doesn't like this. I'm going to get rid of this for right now. Lang is not defined. Lang. Where's lang? Lang. Should be len. All right, let's try this again. Julia, Lucas, Mia. Okay, so it did work. And now I want to start printing some stuff so I know what's going on here. So I'm going to say, let's see, right here. I'm going to print right here. Print indent new perm list, new name list, and I'm just going to see what comes out. See what comes out. Alpha A LPHA beta alpha beta gamma, is that the next one? I don't know. Okay, so all right, so this is the this is perm list, and this is names, and then the next time it's called, this is perm list, and this is names, and the last time it's called, this is all perm list, and names is empty. And so since names is empty, we print out the permutation that we've just created. So now we can see what's going on here. So we print once, we print again, and then we print out the permutation. So we printed, and you can tell by the indents here, see. So this is indented once, this is indented twice, and this is indented 3 times. So the first time, so we enter in the names, that's what we did here, and then we call all permutations, and it comes in here, and size is not 0, size is 2, and so we go down here, and so then we loop. Name list is going to be this. It's going to be, oh, it's going to be alpha, beta, and gamma, isn't it? Okay, so I'm going to do this. I'm going to say, when we come in, I want to come in. I'm going to say, what time is it? Okay, this goes to, how long does this class go to? 4:15. Okay, good. I got a lot of time. All right, so let me just I'm going to print. I'm going to do indent, comma. I'm going to say perm list, colon, comma, perm list, and then I'm going to also print indent, and I'm going to say name list, colon, and then name list, just because I want to see these when they come in. And I'm going to wait on this one. So now let me save this, and let me run this, and I'm going to go alpha, beta, gamma, and what do we have here? Okay, so alpha, beta, gamma. All permutations is called, and perm list has nothing in it, and name list has all these 3 in it. And then it's called again. It's called again, and at that time, perm list has alpha in it, because why? Because it's passed in with new perm list, and new perm list started with the old perm list, which was empty. It appended the first name on it. This is the first name right here. That's the first name. This is the name list that came in. It appended that on it. It made a copy of the name list. So it made a copy of this name list, all 3 of them, and it popped off the last one. So it popped off the first one. Yeah, because I is 0. Okay, it popped off the first one. Here it appended the first one onto perm list, and it popped it off of the name list, and then it called it again. Okay, so now it calls it again, and this is the second calling. We have alpha is So perm list does have it because it was just attached onto it the last time, and name list is smaller. And so now we take the name, we pop it off name list, we append it onto perm list, and now all we have left in name list is this. So we call it again with we call it again, and this thing comes in with this, and it's attached on the perm list. Okay, so yeah, it's attached on, it's called again, and the last time it's called, perm list has all three of these, but name list is empty. And when name list is empty, that's this. Then it knows we're done, so it prints out the permutation that it just created, and that's this. It just, so first it creates this alpha, beta, gamma, then it creates alpha, gamma, beta, because the second time around, you notice here with alpha, beta, gamma, it goes, it looks like it gets called 4 times. 1, 2, 3, 4, because it's called when name list is equal to 3. It's called when there's 3 in name list, calls when 2, called when 2 is in name list, it gets called when 1 is in name list, and it gets called when none is in name list. And when none is in name list, that's when it prints it out. So that's what we see here. Okay. Then it returns, and we were right. We come in, let's see, where's perm list of alpha, beta? Okay, so here's perm list of alpha, beta. Here's perm list of alpha, beta. So see, we return back to when we print out perm list of alpha. This is alpha, beta with gamma. Perm list ends up being called again. This is getting confusing. It looks like perm list this has been appended already. So this is when it's called the second time. This is when it's called the first time, where it appended beta on the gamma, and then here it appended it appended beta onto perm list, and then what's left is anyway, here it appends it on. It appends gamma on first, because that's what's left in the list of names. I should print out the list of names here. That's the remaining list of names. Let's see. Well, all right. So let's do that. I'm going to print out indent, and I'm going to say call again. And new list. And then I'm going to say new name list is that. And then I'm going to say so this is when it's called again. And then I also want to say return returned from. I just want to see that in there. And I'm going to say the same thing again so we can see it. So this is call. I'm just going to put this in. Call with, and this is return with. All right, so let me just see what this looks like. Alpha, beta, gamma. So the first time this is where we did it. Perm list is empty and the name list looks like this. Then we're down here and we have at this point we have, notice we have at this point we have appended alpha onto the new perm list. Here we've appended alpha onto the new perm list, and we have popped off alpha from the name list. We've popped off alpha from the new name list and added it to the new perm list. So that's why perm list has alpha and name list does not have alpha. Name list had alpha when it came in, but when it's just about ready to pass into all permutations again, when it's about to indent, when it's about to recursively call itself again, name list is one short, and that's been added onto alpha. So then we come in again, and this is what it looks like when we come into the top here. Perm list now has this, which is what this is, and name list has this, which is what this is. And it comes down here and it does its thing again. It pops off the beta and sticks it on the end of this. And so that's why that looks like that. And now there's no more beta, so we just have that. And then we call all permutations again. We still haven't returned from the last one. We call it again. And now when this prints out, perm list has got both the alpha and beta, and name list only has gamma. So then we come down here, we produce this, and we see now this loop. So when we get to here, gamma has been added to this list, and it's no longer a name list. So we have gamma now is in here, and name list is empty. So we call it again, and this is when we come in, and since name list is empty, we hit this, and this is where we print the permutation which we just generated. Now we return, and we are returning here. This is this return. This is the call. It's the indenting is the same. We have a call, and then we have a returned, and this is the call, and this is the returned. So this is the call of all permutations alpha, beta, gamma, nameless, blank. This is the return of all permutations alpha, beta, gamma, nameless is blank. And so once we return from this, we come back around and we return again, but now we're returning from this one. See, and this is just alpha and beta with the nameless of gamma, and this is alpha and beta with the nameless of gamma. And then, but then since we're here, we've got alpha and we've got alpha, so we've returned, okay? And then we, so we've returned, but then there's still one more left in here. See, there's still one more left in here. So here's where we return from this. And when we return, see, perm list is still there. See, we have new perm list here, but we go back to what perm list is again. So when we return from here, perm list was this, but this was actually the result of adding the beta onto the alpha. So when we come back to this point here again, we only have this perm list as alpha, and we're on the second of these two now, and so it's gamma that gets attached to perm list, and not beta, because beta was attached before. So here we have gamma attached. So I should do this. I should say I'm going to say here print indent, and I'm going to say copy perm list into new perm list. And I'm going to say, so this is the new perm list. So that's done that. And okay, so I'm just going to do this. Then I'm going to say print, indent, append, this onto new perm list, which is now equal to, and I'm just going to do it this way, new perm list after it's been. And I'm going to say print, indent, remove name list I from new name list equaling new name list. All right, now we should be able to see all the steps. And I think when I talk about the assignment next time, I'm going to just have you refer back to this, because this really should show you the breakdown or the step-by-step what's happening with these recursive calls. So let me save this and run it again. Brighten it up a little bit. And I'm just going to go, and I'm going to do Joe, Fred, Mary. All right, there's a lot of them here. Let's go to the top of the first Joe, Fred, Mary. And so we started with a perm list. The name list looks like that. And so we copy this blank thing into new perm list, and then we append Joe onto perm list. And so now perm list just equals this. And then we remove Joe from new name list. So now new name list just looks like that, minus Joe. And then we call all permutations with the new perm list. This is the new perm list, and this is the new name list. So you see, what we're doing is we go through boom, 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 until we get name list as blank. So we grab the first one, stick it onto perm list, and then we grab the second one and stick it onto the second one and stick it onto perm list. And then we come down here and we grab the last one and we stick it onto perm list. And then since there's no more name list, then we print it out, and that's what this is. And then we return from name list is empty and printing it out. We return from that and we come back here, and then we return from Joe sending perm list of Joe and Fred and the name list of Mary. We return from that, which resulted in this being created, which actually resulted in this being created. And then we copy, so once we return from this one, where Fred has been attached onto the perm list of just Joe, Fred has been taken off of the new list. That's right here, where Fred, return from here. Okay, here, up here, Fred is taken off of, see, Fred is taken off of name list and stuck and attached into Joe, but there's still Mary. Mary's still left, okay? So that's what happens when we come back around here again. We're back here with Joe, and now we've already attached Fred on there. Fred's gone. Now we're attaching Mary, and so we have Joe and this list, and we've already done I equals 0, and next we do I equals 1. So this is when I equals 0, we attach Fred onto the end of Joe, and that just leaves Mary. And then when I equals 1, we attach Mary. It's the second one. We attach Mary on the end of Joe. And when we pull Mary off of the name list, remember the name list has got both these on here. When we pull Mary off of the name list, that just leaves Fred left. And so now we call all permutations again with Joe and Mary as the perm list, and the name list just contains Fred. So then when that comes in, we have the perm list of Joe and Mary and the name list of Fred. We pop off Fred, stick it onto the end, and that gives us Joe, Mary, Fred. Call name list again, or call all permutations again, and name list comes in as empty. So so that's when we print out Joe, Mary, Fred. So anyway, and then this returns back to the perm list of blank, and we have already done Joe. We return from Joe being the only name in perm list, and we return from that, and we start back again without Joe, and that, you know, we start with an empty perm list. We've already tried Joe, and now it's time to try Fred. See, back up here, the first one we did was Joe. And then we did the remaining. And now we've done Joe, so now here we want to do Fred. Because we're doing this loop here. This 0 is Joe, 1 is Fred, 2 is Mary. So we add Fred onto the perm list, and we pop that off of the name list, and now with all that's left is Joe and Mary in the name list. And so then it looks like Joe probably gets attached on next. Here we have Fred and Joe, and then Mary gets attached on, and that's what ends up with this here. And we keep on doing it, and we end up with 6 combinations, where the last one is Mary, and the two different ways you can add 2 names onto Mary. All right, so that's this this one. Let's see, do I have time? Maybe I'll just time to do the next one too. I might as well help you out with that. Okay, Fibonacci sequence recursion. All right, why don't we try to do that? Oh, by the way, you're obviously gonna have to take out all these print statements and put it in there, but you should be able to get it right. All right, let's take a look at this Fibonacci sequence. I got 15 more minutes, so I might as well do this for you. All right, so the Fibonacci sequence begins with 0 and then 1. Then all subsequent values are the sum of the previous 2. So we have 0 and 1, and then it's the sum of the previous 2. So this one is going to be 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 3 is 8. And 8 plus 5 is 13. So it keeps on going like that. And so complete the Fibonacci function, which takes an index and returns the nth, returns that value. So in this case, and if the negative index, it returns -1. So in this case, we entered, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. What's the eighth? The eighth value in the sequence? It looks like it's this one or something. All right. Oh, I guess it's this one. 1, 2, 3, 4, 5, 6, 7, 8. Oh, index starts with 0. All right, that's fine. Okay, so it's this. So I'm gonna copy this over here. I'm gonna it's okay. I don't need to save this. So this is it, and I'm going to write the Fibonacci function up here. And so here's where we call the yes, this is where we call the function right here. So we're going to write a Fibonacci function up here. So I'm going to say def Fibonacci, and it's going to have a number that comes in. And the first thing I'm going to do is if n is less than 0, then we're going to return -1, an error. Otherwise, if n is less than or equal to 1, well, if n is equal to 1, then return 1. Otherwise, so I'm supposed to add, so Fibonacci, so this is 0, this is 0, this is 1. So Fibonacci 2 is equal to Fibonacci 1 plus Fibonacci 0. Fibonacci 3 is equal to Fibonacci 2 plus Fibonacci 1. Fibonacci 4 is equal to Fibonacci 3 plus Fibonacci 2. Fibonacci n is equal to Fibonacci n minus 1 plus Fibonacci n minus 2. So I would say that fib, I'm just going to say this, fib of n is equal to, and these are recursive, right? So Fibonacci of n minus 1 plus Fibonacci of n minus 2. And so that's what Fibonacci of n is, and that's what we can return. Return fib of n, fib n. Oh, n minus 2. And so so n has got to be at least 2. If n is 0, it's gonna, oh, I gotta do, oh, if n equals, so this is not, I forgot about, oh, I gotta do else. Doesn't really matter, I guess, does it? So if n is 0, it returns 0. If n is 1, it returns 1. If n is less than 0, it returns -1. If n is 0, it returns 0. If n is 1, it returns 1. And if n is 2, it's going to return Fibonacci of 1 plus Fibonacci of 0. If n is 3, it's going to return Fibonacci of 2 plus Fibonacci of 1. So, you know, this might just be all we need. I don't know. Let's see. Enter an index. Okay, so enter an index. So run, enter an index 7. Oh, it's 13. Fibonacci 7 is 13. Forget about all this. CLS. Let's run it again. And I'm going to put 20. Ooh, all right. So anyway, I think that's all we need to do for this problem. So you can fix this up and submit it. It's 4:08. I guess it's a little early. So next time, I promise I will have the next assignment. I might have 2 assignments. I'm getting pretty behind up with these assignments. And after that, I guess we're gonna get into we're gonna get into searching and sorting. That's fun stuff. All right. You got any questions?
So is the assignment number 2 done by the auto grader, or how is it?
Yes, it'll be done by the. I'm going to try to make
Okay.
everything an auto grader, so you know you just stick with it. And you're also debugging my auto grader, so if it runs and the auto grader says you didn't get it right, you go, I'm sure I got this right. You just email me, and I'll go in there and I'll check to make sure. And you know, it could be a case that I didn't consider or something like that. So I'm glad you guys are helping me out with that too. All right.
Okay, thank you, Dr. Harrelson.
Okay, very good. See you next week.
Okay, see you next week.
Good day.
All right.